Welcome to another tutorial on Matlab. In this particular tutorial series, we are looking into the concept of plant modeling and how it is related to Matlab and Simulink. In the previous tutorials, we have seen how we have created the Simulink models using the mathematical equations, which is somehow called plant modeling in the Simulink. In these particular videos, we are looking into how we can develop plant models in scripting environment and how it can be used while simulation. In the last video, we have seen a train system which has a engine, and along with that there is one bogie attached behind it, and based on that analysis we have developed the state space equation, which is related to the displacement and the velocity of the two masses. So the first mass is of the engine and the second mass is of the bogie. So based on that, we will be doing the further programming in Matlab, and we will be developing the Simulink. We will be developing the Matlab plant model, and we will be seeing how it behaves over a simulation time. So at the beginning, we need to do clear all and CLC and close all in case any figure is opened, and we will be clearing all the variables, plus we will be clearing the screen from the command window to remove all the previous output that are there in the command window. Next is we will be defining the sets of parameters for this entire system. So the first is the spring constant. So spring constant is the joint representing the connection between the engine and the bogie. So that is for the spring constant. Mass m1 represents the mass of the engine, mass m2 represents the mass of the bogie, and here mu represents the coefficient of friction over here, so that is 0.05, and the g represents gravitational acceleration constant, which is 9.81, and here we will be applying 100 Newton of force, which will be applied in this direction. So based on this, we have created all the relevant parameters that we need to have to design this entire system. Next is to develop the matrix equations. So as you already know, this is the dynamic equation, and in which we have A, which is this one, the transformation matrix, state transformation matrix, and B is the input matrix. So these two we need to write. So as per the matrix, we have written it here for the A matrix, and here it is for the B matrix. And also we need an initial condition where we will be saying like we are at rest, and basically the velocity for mass 1 and displacement for the mass 1 is 0, and here we are telling that for mass 2 also it is 0 for both displacement and velocity. We will be defining next the time which is the initial time, and then we will be defining the final time of the simulation. So the simulation will start from the 0th second and it will end at the 3rd second, and you will be getting this time interval, which is 0.02. so every 0.02 times it will take the sample, so every gap is 0.02 in between this line, which is the timeline of the simulation. So in the next we will be seeing the entire simulation, which will be running on a for loop. So as we already have defined the time, now we need to define how many iterations I need to run for the simulation. So that is defined with this number. So basically it is telling that whatever the time gap is there and what is the time interval in between that time, we will be counting everything and rounding it up to a particular number. So that number will be the iteration. So next we will be simulating the system. So this is for performing the simulation of the system. So basically the entire system will be simulated over time, which is for an example, like multiple runners are there. Suppose in a competition, suppose this is the velocity for the mass 1, this is the this is the displacement for mass 1, and this is the velocity for mass 2, and this is suppose velocity, or this is displacement of mass 2. So we can see every time instant, like whatever the values that they are getting when they are like simulating, when the simulation is going on. So that can be done with the help of the state space equation. So let's look into the same, how we will be iterating it over time. So first of all, we need to set the current state. So this is how it will look. So suppose this is the entire row column format of the matrix that we will be creating over time from the simulation. The first column will be in this one is the time. So this is the time part, and the remaining part, which is the 4 element velocity and displacement part, that will be stored over here like this. And we will be getting multiple data when we will be simulating. The first data will be the initial data that will be going here. So that is the current time, which is the time, and the current positions, like for displacement it is 0, and and for velocity and for both the masses it is 0. So that is taken into consideration, and we are recording that as the first initial state. And next we will be calculating the change in the state. So we have given the initial state, we have given the input matrix and the input plus the state transition matrix. So based on this we will be calculating like how much is the deviation is happening in the state of the system, and by calculating this deviation we will be then updating the state based on dt. So the time difference into the change plus the current state. So basically this is integrating over time, like how we are changing it like this. So suppose you got the change, then you are adding the change to go to certain level. So that is how it is happening here. So basically it is changing the state of the system over time. And next at the end we are updating the time, and suppose currently you are at 0th second, then the next sample time you will be at 0.02 second, as here the dt is 0.02, then you will be at 0.04 in the next iteration. So like this way you will be continuing till 3 seconds. So this will collect all these data, and it will be stored inside the variable x1. So every time any new state is getting updated, it is stored in the variable x1. And at the end we will be starting the plotting part. So in this entire simulation, in the for loop, we just collected the data and we have stored the data for displacement, velocity, and then again displacement and velocity for different for the two masses. And then we will be plotting it here in the plots, like and we will be giving it with some labels. So basically here we are taking that x1 column, first column. So here this part represents the row, so every index representation is like this only, and this is for column. And here you can see like column means every row, so here we are taking every row of the t variable. So basically this is the first part of this x1, so everything over here, so we are taking everything here and the first column, so this column itself, which is represented here in the column. And next is x1, so again x1, but we are taking the data from 2 to 5 in the columns, so this is also the column, so from 2 to 5, which means this entire all columns and the entire element like every row. So here this is representing R, so you need to have every row. So basically it is representing this entire data set which we need to present here. So basically this is collecting all the data, and next we are just plotting with the help of this plot command inside this, and we are giving some relevant information like x label, y label for labeling the axis, and title for the labeling of the title for the graph. Grid on is turning on the major grids, and grid minor is for turning on the minor grids, which is of the smaller grid size. And next at the end we are putting legend. So legend will tell like which line is for which variable, so this will be easy and helpful for us. When we directly see the plot, we can recognize which is represented in which data and which color. So that is what I was talking about. So every color is represented here, and you can see which color represents which variable over here. And this is how you will get y label here, and you will get x label here, and this is the title part. And with the simulation you will get these smaller grids. So these smaller grids are coming from grid minor, and the bigger grids are coming from grid on. So this is how you can do simulation. So the first step is setting the parameters all related to system, then setting the parameter related to the time, and then defining the system equations which is in the state space format. And based on that state space format of equation, you can iterate it over a for loop, and you can get the variation of different states over time. And at the end, once you done the simulation, then you can present it in the form of some plots like this. So this is how the entire workflow looks like, and this is the basic thing related to the implementation of plant model in a mechanical system. So the previous example and the current example which we have seen now is more related to mechanical example, but we will be covering some electrical examples as well in this particular tutorial series, so that it will be helpful for understanding the electrical systems. So basically it deals with the mathematical equations only, so it is independent of any domain, but still we need to look into the same as a different domain perspective. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please share it in the comment box. It will help us to improve the experience of learning MATLAB in this channel. And happy learning MATLAB. Have a good day.